Here we're going to talk about what are called the half angle formulas, and we're going to start off by recalling the double angle formulas. And the forms of the double angle formulas that are useful, the first one is this: cosine of 2x is equal to 2 times cosine squared of x minus 1. So what we're going to do is we're going to isolate this cosine of x here. So we're first going to add 1 to both sides and then divide by 2. So it's going to become 1 plus cosine of 2x divided by 2 is equal to cosine squared x. And now what we'll do is we'll go ahead and write the cosine squared x on the left-hand side. So we've got cosine squared x is equal to 1 plus cosine of 2x divided by 2. And now we'll go ahead and use the square root property. So that generates a plus or minus the square root of the right-hand side. So cosine of x is equal to positive or negative the square root of 1 plus cosine of 2x, all divided by 2. Now, often what people do is they make note of the following fact, that what's here, right, is half of whatever's there. So we can write that out explicitly in the following way. That is, if you divide this by 2, then you divide that by 2 as well, right? Because these are the same x. So we can write this in the following way. Cosine of x divided by 2 is equal to plus or minus the square root of 1 plus, now if you divide this by 2, 2x divided by 2 is just x. So it's just cosine of x over 2. So written like this is called the half angle formula because I see that whatever is here, right, x over 2, is half of whatever's here, which is just x. So this is called the half angle formula. Now it turns out you can use the half angle formula in whatever form you'd like. You could use it in this form if you want as well. Now if you use it like this, then this is still half of that, right? And what I can see is that this, if you take this is, I take that and I double it to get this. That's the same thing, of course, as saying that this is half of that. Now it turns out we can also derive a double angle formula for a sine. And we're going to start off with another double angle, we can derive a half angle formula for sine. And we're going to start off with a double angle formula for another double angle formula for cosine. And that's going to be this. Cosine of 2x is also equal to 1 minus 2 sine squared x. So we derived these in the video double angle formulas. So now what we'll do is we'll isolate that sine squared x. And we'll do that by, why don't we first add 2 sine squared x to both sides. So we get 2 sine squared x is equal to, it's going to be 1 minus cosine of 2x. And now let's divide by 2. So we're looking at sine squared x is equal to 1 minus cosine of 2x, the whole quantity divided by 2. And now we're going to again make use of the square root property. So we're looking at sine of x is equal to plus or minus the square root of 1 minus cosine of 2x, all divided by 2. And so this is a perfectly acceptable form of the half angle formula. But what you can do is you can make use again, you can divide this x by 2, and that of course means dividing that by 2 as well, and you'd get a similar form to that one. So you'd get sine of x over 2 is equal to positive or negative the square root of 1 minus cosine of x over 2. Okay? So these two together are called the half angle formulas. Now you should know that there's also a half angle formula for tangent. We won't write it here, but you can find it in your textbook if you need it. And you basically get that formula for tangent by simply dividing the one for sine by the one for cosine. Okay, so a couple things to note about this. First of all, there's this plus or minus, and in problems you have to decide which of those you want in both formulas. The second thing is that we mentioned is that these come in different, you can use whatever form you want. You can use this form or you can use that form. Now if you use the form above it even, these forms are called power reducing formulas. So when you use any of these four right here, these are called half angle formulas, but if you use these two, these are called power reducing formulas because you go from square something squared to just something to the first power. Okay, let's see how to use these. Some examples. Let's find sine and cosine of 7 pi over 12. So first of all, 7 pi over 12 is a little bit awkward because it doesn't have one of the denominators we like, right? We like seeing things like this. 3 pi over 4, we like a denominator of 4. Or 5 pi over 6, right? Multiples of pi over 6. Or like negative, 8 pi over 3. We like one of these denominators, 3, 4, or 6. Now what we can do is we can connect the 12 to one of these denominators by making use of the fact that if you take the angle 7 pi over 12, let's just notice this, that if you take 7 pi over 12 and you double it, that is if you multiply it by 2, well, it's like 2 over 1, right? And then these would cancel and you'd get 7 pi over 6. Now you can't just magically convert this to 7 pi over 6, but I'm just making use of noticing that 7 pi over 12 doubled is 7 pi over 6. And the reason that's relevant, let's go back to our formulas now on the previous page, is I see that, if I have an angle here, for example, if I double it, I get this expression over here. And so if I have, 7 pi over 12, this would be 2 times 7 pi over 12, which is 7 pi over 6. And I can evaluate cosine of 7 pi over 6 and cosine of 7 pi over 6 as well for this one. Okay, so the point is that even though you can't handle 7 pi over 12, you can handle double that. And that's relevant because it's the right-hand side of the half-angle formulas. So back to our problem now. So we're asked to find sine and cosine of this angle. So let me write down one of the formulas. Let me write down that sine of, well, let's write our double angle formula. So sine of, well, it's going to be x, right? So sine of x is plus or minus the square root of 1 minus cosine of double that angle. Okay, this is a form of the double angle formula. So, and the same thing is true for a cosine, right? That cosine of the angle, right, is equal to plus or minus the square root of 1 plus cosine of double the angle. These are the alternate forms of the half angle formulas. So what that means here for us, right, we want sine of 7 pi over 12. So sine of 7 pi over 12, I have no idea, right? That's really hard to evaluate because 12 isn't one of our special denominators. But that's equal to, well, plus or minus. Now, first of all, we have to decide, is it positive or negative? Well, 7 pi over 12, right, what I can notice is that, let me write it up here, 7 pi over 12, well, it's definitely less than 12 pi over 12. Okay, now 12 pi over 12 is just equal to pi. So the angle is definitely less than pi, but it's also greater than 6 pi over 12. And 6 pi over 12 is the same as pi over 2, which means that our angle here is it's greater than pi over 2, but it's less than pi. Okay, so that means it's in quadrant what? Let's see, that'd be quadrant 2, right? It's greater than 90 degrees, but it's less than 180 degrees. So sine of that angle would be positive, right? Sine of an angle in the second quadrant is positive, so I'm going to choose the plus sign right here. And then I can write, once I've chosen that sign, the square root of 1 minus cosine of double the x. Well, double the 7 pi over 12 is 7 pi over 6, right? Over 2. That's the important point, that this is double that. And the reason that's relevant, of course, is because cosine of 7 pi over 6 is something we know how to handle. So this is going to be the square root of 1 minus, let's see, cosine of 7 pi over 6 is going to be negative, right? It's going to be negative root 3 over 2, and then all over 2. So this is the square root of 1 plus root 3 over 2, all over 2. Now, what I'm going to do is I'm going to clear fractions under this large radical. So I'm going to multiply top and bottom by 2. So let's write that as 2 over 1, and then 2 in the denominator as well. And what that gives me is the square root of, well, I have to take the 2 and distribute, so it's going to be 2 plus, and then the whole point is that these twos cancel, root 3, right? And then over 2 times 2 is going to be 4. And we can go one step further because the square root of 4 is 2. So our final answer is going to be this. It's going to be the, if I take the square root of the numerator and the denominator, I get the square root of 2 plus the square root of 3, and then over the square root of 4, which is 2. Okay, and that's sine of 7 pi over 12. Okay, let's do the same thing now, but with cosine. Now, cosine x, there's good news here, right? Because this formula makes use of cosine of 2x, and we already know what cosine of 2x is, right? It's cosine of this, which is negative root 3 over 2. So it's going to be, in this case, we're going to get sine of, whoops, make that not sine, but cosine. So we've got cosine of 7 pi over 12 is equal to, now once again you have to make a decision, positive or negative. Now remember we're in quadrant 2, right? Sine of, or 7 pi over 12 is in quadrant 2. And cosine of an angle in quadrant 2 is negative. Whoa, tricky, right? And then you still have square root of 1 plus, right? So 1 plus cosine of, this is going to be 7 pi over 6 for the same reason it was over here. And we saw that cosine of 7 pi over 6 is negative root 3 over 2. So it's 1 plus negative root 3 over 2, and then all over 2. So we're looking at negative square root of 1 minus root 3 over 2, all over 2. Once again, multiply top and bottom by 2 over 1. So it's going to be negative, let's see, square root of, well, it's going to be 2 minus root 3 over 4. And then finally, if you break that up, you're going to get finally that cosine of 7 pi over 12 is going to be negative square root of 2 minus root 3 all over the square root of 4, which is 2. So these would be our answers. Okay, so remember you have to choose the positive or the negative, and then you also have to be able to evaluate whatever is under the radical for these problems. All right, let's try another example. All right, let's find the exact values of sine of u over 2 and cosine of u over 2 given some information, given that sine of u is negative 3/5 and u lies between pi and 3 pi over 2. So first of all, what do I want to find? I want to find the values of sine of u over 2 and cosine of u over 2. Let's write that down. So I'm going for, first of all, sine of u over 2. Now I know from the half angle formula that sine of u over 2 is, well, it's positive or negative, right? The square root of 1 minus cosine of u over 2. Now you might say, well, why is it cosine of u? Why is it not cosine of 2u? The answer is because we're using a different form over here, right? It's u over 2. And this is always double that. So if you double that, you get cosine of u, or you get just u right here. So remember, let's go back to our first page, just to recall this. Our first page was this, right? We're using this form now, right? This is half of that. Okay, now if this is x over 2, this is just x. In the previous problem, we used this one, right? It was x, and this is still half of that, but we just used a different form. Let's go back to our problem now. Okay, so that's the expression we're after, right? Now, look what we have to do. We have to do two things, right? We have to pick, positive or negative once again, and we also have to be able to evaluate cosine of u. So we're going to need that cosine of u, and they give us sine of u, close, right? But not quite cosine of u. Let's first think about what cosine of u is. So the way we're going to do that is we're going to think about, let's write it over here, that we know that sine of u is negative 3/5, right? Now remember, sine can always be regarded as y over r. So I'm going to write this as negative 3 over 5. Now the reason I'm doing that is because when you think about it as y over r, so let me write that's equal to y over r, you want the r to always be positive. And the y here has to absorb the negative. So I'm thinking that y, the way I wrote it, right, y over r, y is negative 3, and r is equal to positive 5. Now the reason I'm doing that is because I want to find out what x is. And the reason I want to do that is because I want to find out what x over r is, because I need cosine of the angle, right? And cosine is x over r, and sine is y over r. So let's find out what the x has to be. So I know, of course, that x squared, right, is equal to r squared minus y squared. So x is equal to, well, x squared is equal to r squared, which is 25, minus 9, or 16. So x is equal to positive or negative the square root of 16. Now the question is, should x be positive or negative? And u, right, we're given here that u lies between pi and 3 pi over 2. Now that's in quadrant 3, right? And the x-coordinate in quadrant 3, is that positive or negative? That's negative, actually. So we get x is equal to negative 4. All right, see how that worked? We said, oh, the angle, u is between pi and 3 pi over 2, so the angle u is in the third quadrant, and the x-coordinate for an angle in the third quadrant, the x-coordinate is negative, and so is the y, right? But the x is what we're after, so that means that cosine of u is x over r, right? So it's x over r, and x is negative 4, and r is 5. So we get negative 4/5. And I had to find that because I'm going to plug that negative 4/5 in right there. Now, the second issue we have to deal with is we have to decide between the positive and the negative. Now you might say, wait a minute, we just chose it. That's not true. We chose a negative because we were thinking about the angle u. When you choose this positive or negative, you're thinking about u over 2, right? Now sine of u over 2, this is not u, this is u over 2. So is sine of u over 2, is it positive or negative? Well, going back to this relationship, right? If u lies between these angles, well then isn't it true that u over 2, that is if I divide all of these by 2, isn't this true, right? I divide the left by 2, I divide the middle by 2, and then if I divide this by 2, I get 3 pi over 4. Now what that means is that if u is between pi and 3 pi over 2, u over 2 is between pi over 2 and 3 pi over 4. And that puts us in quadrant 2. That's tricky. U is in quadrant 3, but u over 2 is in quadrant 2, according to this relationship, right? Between that less than 90 degree, or make that greater than 90 degrees, but less than, what would that be, 135. So that's in quadrant 2. Now sine of an angle in quadrant 2, oh, is that positive or negative? That's positive, right? Sine of an angle in quadrant 2. So that means we're dealing with this. Sine of u over 2 is equal to the positive, right? It's going to be positive square root of 1 minus, and then cosine is negative 4/5 over 2. And that's equal to, let's write it here, the square root of, 1 plus 4/5 over 2, right? And then I can multiply top and bottom just like before by 5 over 1. So bottom by 5 as well. And I get this. I get the square root of distributing the 5. It's going to be 5 plus 4, or the square root of 9/10. And that's sine of u over 2. Positive 9/10. Okay, so that's the first part of my first answer. Now we're also asked to find cosine of u over 2. Let's write this down. So cosine of u over 2, that's equal to, well, plus or minus the square root of 1 plus cosine of u over 2. Now once again, you have to figure out what cosine of u is. We have that, right? Once and for all, it's negative 4/5. That's the good news. But you have to decide between positive and negative. Now remember, u over 2, we said, was in quadrant, this angle here, was in quadrant 2. And in quadrant 2, cosine of that angle is negative. So it's going to be negative, right? Square root of 1, and cosine of u is negative 4/5, so minus 4/5 over 2. So it's going to be negative square root of, let's see, let's multiply top and bottom by 5 again. So we're looking at 5 minus 4, right? Distributing, it's 5 minus 4 over 10. So it's going to be negative, let's write it as square root of 1 over 10. And that's cosine of u over 2. All right, so this is our second, this is the second part of the answer. Okay, so once again, kind of tricky, right? You have to find this angle, or cosine of that angle, cosine of u, but then you also have to deal with this sine afterwards by making use of that relationship. Okay, let's try one more. Let's simplify using the half angle formula. So I look at this, and the first thing I notice is it has a form that we recognize, right? I recognize right away this looks a whole lot like the square root of 1 minus cosine of 2x over 2. Now, I know that that's equal to sine of x, right? Now, what's important to notice here is that whatever you have here, right, once again, whatever's there, this is double that. Okay, it doesn't matter what it is, as long as you recognize that when you take this, you double it to get whatever that is. So my question to you is, this is going to be sine of something. Okay, what should that something be such that you get all of this? Well, if this is sine of 4x, isn't it true that if you take that 4x and you double it, you'll get the 8x? And that's exactly why this whole expression is just sine of 4x, because it has the form we want, and if I double the 4x, I get the 8x right there. In other words, this is really a half angle formula in disguise, right? Okay, so that covers the half angle formula. Until next time.